The sky darkens, the wind picks up, and a low rumble echoes in the distance. We've all experienced the powerful presence of a thunderstorm. These common weather events are often seen as simple rainstorms, but they are a fascinating display of atmospheric physics. Understanding them can help us better appreciate their power and even stay safe. Having watched countless thunderstorms and studied weather phenomenon as it relates to aviation, I'm here to share some of the science behind these magnificent events. Today, I'm going to explain how thunderstorms form and dissipate, describe their key characteristics, and break down some of the different types you might encounter. First, we'll look at how a thunderstorm is born and how it dies. Then, we'll discuss how it moves and what it produces, like rain and hail. Finally, we'll explore the different classifications of thunderstorms. To begin, let's talk about the life cycle of a thunderstorm. A thunderstorm isn't just a random event. It's a predictable process driven by three specific ingredients: moisture, unstable air, and lifting action. Moisture is the fuel. Unstable air provides the rising motion, and lift is the trigger that gets the whole process started. Once these three elements are in place, the storm goes through three distinct stages. The first is the cumulus stage, where warm, moist air rises and creates a towering cumulus cloud. This is a time of strong updrafts and very little precipitation. Next is the mature stage, the most violent and active period of the storm. The cloud's top has reached a point where it can no longer rise and precipitation begins to fall. As rain and hail fall, they create a downdraft that now exists alongside the powerful updraft. Finally, the storm enters the dissipating stage. The downdraft becomes stronger than the updraft, cutting off the supply of warm, moist air. The storm essentially chokes itself out and the clouds begin to dissipate. Beyond its life cycle, a thunderstorm has several key characteristics. During the mature and dissipating stages, thunderstorms produce powerful downdrafts. These are common and can be extremely hazardous, especially for pilots. These concentrated downdrafts are called microbursts, and they can produce wind gusts of over 100 miles per hour. These storms also produce heavy precipitation and can generate updrafts strong enough to form hail. Hailstones grow by being repeatedly carried up and down in the storm's up and down drafts, thus accumulating layers of ice. This hail and the hazardous turbulence associated with it can extend up to 20 miles from the storm cell. As pilots, this is vital information when navigating around these perilous conditions. Finally, it's important to understand that not all thunderstorms are the same. They are classified into different types. The most common types are single-cell and multi-cell thunderstorms, distinguished by their size and duration. Single-cell storms are typically small, short-lived, and not very severe. Multi-cell storms, however, consist of a cluster of single-cell storms at different stages of their life cycle, making them more powerful and longer-lasting. There are also more complex types, such as squall lines, which are long, organized lines of thunderstorm that can stretch for hundreds of miles. Additionally, there are also embedded thunderstorms, which are hidden with thin, larger layers of rain or clouds, making them particularly dangerous for aviation because they're harder to see. We've now seen how thunderstorms are born from a precise recipe of atmospheric conditions, how they are defined by the unique movement and precipitation, and how they come in many different forms. The power we see in a thunderstorm is a result of a predictable life cycle, a distinct set of characteristics, and its classification into various types. The next time you watch a storm roll in, you'll have a new appreciation for the complex and harmonic dance of nature that is happening right before your eyes. Finally, I would like to cite the Aviation Weather Handbook, also known as FAA Document Hotel-8083-28 Alpha, for providing me with the weather information, and Grammarly for providing an outline for a topical speech. Thank you.